Hello, welcome to Mathematics on Long Road. My name's Steve Warr and I'm the course team leader for A-Level Maths. I'm going to just run through how we organise the maths course in this presentation. We'll start with some course details. In order to do any A-Level at Long Road, you need to have at least 7 GCSEs at grade 4 or above. And to do maths in particular, you need to have at least a grade 6 in your GCSE maths and at least 2 further grade 6s in a couple of sciences, and that can be either physics and chemistry or also science and additional science. And what's really important is that you have a really good grasp of your algebra, because that's a really important part of the A-level course. So one of the purposes for the summer work that you'll do in due course is just to help you make that transition between the GCSE course and the A-level, just to make sure your algebra skills are secure before you start the course. Okay, this next slide just takes you through how the assessment works. Now, we do the Edexcel A-level course, and that's assessed entirely by examination at the end of the year 2. And there are 3 written papers we have to do, and there's no coursework at all. So this table shows how it works. So paper 1 and paper 2 is all the pure maths from the 2-year course. And then there's a separate paper 3 that covers the mechanics and the stats, the so-called applied work for the 2-year course. And I think one nice thing about the Edexcel course is it's the only exam board that actually keeps the applied work examined separately from the pure work. And I think we feel that that just helps our student, it just makes it easier to revise. The other point I'd like to make here is that most of our students end up taking the A-level exam at the end of 2 years. But we do have a small number who we can enter for the AS exam if we feel that would be a more suitable option. Okay, this slide just shows you a little bit more about how the course content works. So we have 3 90-minute lessons a week, and the first 3 units are what we call the AS content for year 1. So we cover all the pure maths, and then we do all the mechanics and all the stats. And then the units 4, 5 and 6, that's the second year part of the course, which is the so-called A2 maths. And again, we go through all the pure maths, and then we cover all the mechanics and all the stats. So I'd just like to give you a little flavour for some of the things that we do. So in pure maths, for example, we do something called calculus, differentiation and integration. That's a really important part of the course, which we do in both the year 1 and the year 2. So a good example of that is something called optimisation. Just imagine you've got a sheet of card and you cut 4 little square corners out from each of the 4 corners, and you fold the sides up to make an open top box. So one question you might ask is, well, how big should I cut out my little corner squares so the volume of the box is as large as possible? Now, it turns out that you can use a branch of mathematics called differentiation to solve that problem, and something you'll do in the first year. Just to illustrate the mechanics, so in the second year we do a topic called projectiles. So just imagine that you're in some sort of siege situation, and you've got someone with a cannon trying to fire cannonballs at a castle wall. So one thing you might say is, what's the speed and what's the angle that I have to project my cannonball so it hits the castle wall at the correct place? Well, that's all something to do with projectile motion, and that's part of the mechanics that we do in the second year. So mechanics is all about the physics, really, of force and motion. The other applied part that we do is called statistics. And an example of statistics in year 1 would be, say, a binomial probability calculation. So let's have a think. So just imagine that you've got a machine that's making components for a factory, and you've got a crate of, say, 100 components. And if we just said, for example, that, I don't know, 2% of those components are faulty. So you've got the factory inspector that comes around just checking that everything's working okay, and they might want to ask, well, what's the probability that, say, 5 of the components in this box of 100 are faulty? Well, we could work that out by doing something called a binomial calculation. And then that also takes us into a topic called hypothesis testing, because if the factory inspector starts to think that something's gone wrong with the machine and it's not working correctly, then you'd have to stop the whole production line and check the machine and adjust it. And that could be a really expensive and time-consuming thing to do. So what hypothesis testing is all about is asking the question, how can we be confident that we've got enough evidence that actually the proportion of faulty components has increased? So rather than it being 2%, it might have gone up to 5% of the components are faulty. And if that was true, that's too much risk, and we need to reset the machine. So we do some work in statistics that helps us answer questions like, well, how do we know that if things have actually got worse and we need to make the change? Okay, so that's what we do in the course. Now this little table here gives you an example of a summary from the textbook. There's an awful lot of material to cover in this course, and each chapter of the textbooks has like this summary of key points, and we find that students just like to have an overview of the material that's got to be covered and all the key points. And we've also got something called a unit review booklet, and this is an example from there. It's something that's available in our virtual learning environment on Moodle. And again, you've got the summary points from the textbook, and then you can refer to the textbook exercises and examples for an explanation about how that works. And then that all links to our unit review, where the whole course is broken down into nice simple objectives, and you've got some exam questions that actually relate to each of those objectives. So it's a way for students to manage their own learning and to test themselves to make sure they understand all the key points they've got to learn about. So the next section is about what you need to study the course. So we do provide textbooks for use in the classroom, but we also find that some students like to purchase a copy of their own textbook. So these two pictures here show you the textbooks we use in the first year. There's one for the pure and there's one for the stats and mechanics. The other thing that we ask students to get is an advanced scientific calculator called the Classio Class Whiz. This costs about £20, and it's something that you can get from the college shop or from lots of independent retailers as well. And that's a really useful calculator that covers everything you need for both the Year 1 and the Year 2 course, and it also does the maths and the further maths course as well. Now, most students have smartphones these days, and we encourage students to download a couple of really useful graphing apps. So there's two examples here. There's Desmos and there's GeoGebra. And they're really, really clever little bits of kit, which means that you can graph equations and really visualize the maths and see what's going on. So that saves you having to buy an expensive graphic calculators, and we use those a lot in the classroom. Now the next slide is really important. That's talking a little bit about the independent work that we do and how assessment works. So this is a little screenshot from our scheme of work. And you can see that the content for the course is broken down into little weekly chunks. And then how's that assessed? Well, at the end of any particular week, students will do one of two things, either a homework or a quiz. Now, a homework is just a piece of work that the student has a week to work on, and it's handed in and it's marked by the teacher. Then on alternate weeks, we do something called a quiz. And this is like a little mini test we do in class for 15 or 20 minutes. So students have to do prep work for the quiz, which is a series of questions from the textbook. And then once they come to the lesson, they do a 20-minute quiz, like a small test. And those questions are similar to the prep work questions. Now, the homework, as I said before, is marked by the teacher. And then teachers are really good at giving detailed feedback so students can improve. And the quizzes, we get students to mark in class. So we teach them to use mark schemes. And it's practicing working under exam conditions. The other thing that's important is that we ask students to do 4 or 5 hours work a week outside of class, and it doesn't take 4 or 5 hours to do the maths homework. So students are guided to study independently by the teacher, and there's lots and lots of resources you'll see that they can use to do some extra study. And that's used in conjunction with some key assessments. So college, over a course of 2 years, has 6 key assessments, 4 in Year 1 and 2 in Year 2. Now these are mostly actual exam papers that we can use to give students a formal grade, A, B, C and so on. And it's an opportunity for them to see how well they've understood the course at that particular point, and then we give detailed feedback on a question by question basis, so students know what they need to improve and they know how to improve as well. Okay, so the next section is about how we support students. So I think the first thing to say is we've got a great committed bunch of teaching staff in the maths department, and they're really good at offering their support. So it doesn't matter if it's in the lesson or outside of lessons, teachers are more than willing to spend time with students and help them. The textbooks that we use are really, really excellent, and you've got 24/7 access to those on the digital ebook platform. This little screenshot here shows an example of the textbook. So you've got lots of clearly presented examples. Then you've got exercises that focus on technique and then on problem solving. And this little icon here is a little link to the ebook version of this, where you've got a completely detailed, fully written set of solutions for the whole exercise. And those solutions are available for every single exercise in the textbook. So that's a really, really good use that we make use of. And another resource that we've got, which complements the textbook nicely, is a sequence of PowerPoint files that break the course down into nice, easy to follow chunks. And again, these are accessible 24/7 on our virtual learning environment called Moodle. Now, this screenshot here shows that the course is broken down into chapters. So there's a single file on Moodle for every chapter of the textbook, and within each one of those files there is a set of files which are the PowerPoints I mentioned before, and there's a separate PowerPoint for each of the separate sections in the textbook. And then you've also got some additional worksheets and solutions as well. So it's a really well organised resource that students can work independently. Okay, the other important part of how we support students is the workshop that we use. And we have two main types. We have what we call small group talk workshop support lessons, and fairly early on at the start of the course, in year one and also in year two, we identify students who we feel might need a little bit of extra help just to make sure that they understand the work to the best of their ability, and we put on an extra 90-minute lesson on top of their other 4.5 hours, where we do some additional small group teaching, going through aspects of the course that we know are found quite difficult. And then we also have what's called a drop-in maths workshop, which happens twice a week, and that's free to any student just to turn up to get help with any particular thing that they're doing at that time. We also spend a lot of time working with stimulus students from the University of Cambridge. These two diagrams here show a couple of examples. On the right here, this was a fourth-year PhD student from university who came and spent some time doing step tutor lessons with one of our further maths students, and that was something that they found really, really valuable. On the left-hand side here, we have another stimulus student from university just working with a group of students on a car activity, you can see there. So the university students, we have quite a few each term, and they're a really valuable resource that we can use to work with individual students and also with groups as well. Okay, so I said in one of the earlier slides that the whole course is assessed by examination at the end of 2 years, and so that's really important that students are well prepared for those exams. Now, Edexcel as an exam board is really good. The past papers and the specimen papers they provide are really, really good quality. The papers and the language are really accessible and very clearly laid out, and the mark schemes are also very easy to follow, very clear, very detailed, showing what you have to write down to get the particular marks. So that's a really useful resource that we make available on Moodle for students to prepare for their exams. Okay, so now we'll have just a little bit more of a few general points. So we think it's really important that we focus lessons on making sure that students comprehend the material that they're being taught, and they also have sufficient time to practice the work that they're being taught. So these two photos here show you some examples of the things we do. So individual work on exercises, problem solving, sometimes individually or pairs, or sometimes in groups. As I said before, we've got those nice apps on the phone that we can use to do graphical work, and these two photos show examples of card matching activities which are very popular as well. Okay, now I would say about 50% of our students go on to university when they've completed the maths course. And this is just a selection of some of the destination courses that students did in the last year. So you can see you've got a nice range of Russell Group universities there: computer science at Warwick, chemistry at Warwick, and then you've got some maths and economics there at Essex, textile design, Science and Engineering Foundation course at Queen Mary's in London. So we've got a whole range of courses there, and that's a really important point, because maths is what we call a facilitating subject. So it's really a subject that goes with all possible course combinations you could possibly imagine, and it just opens doors to a whole range of different options for progression moving forwards. So it's a really, really important course. That's why it's so popular. And this is a really good website for careers. As I said, maths really does open doors, and you can do specialist maths degrees or joint honours degrees with maths and other subjects, or just lots of other degree courses where it's really useful to have done A-level maths. And sometimes maths is just good for the general logic and problem solving. This is a nice little website if you're looking for inspiration for something interesting to read, or just looking for some ideas and so on. So it's well worth a look. Okay, trips and visits are an important part of what we do as well. We have a really nice cohesive bunch of students at Longroad, and they all get on really well together. So every year we take a group down to Royal Holloway College in London to do what's called the Exploring Maths Conference, and that's a really nice day out. And they have opportunity to tour around the university, attend lectures about how maths works at university, different small group sessions on a range of topic. And as it says there, they even had a talk about the hidden maths in technology by a stand-up comedian. So a whole range of nice opportunities there for students to take part in. These are a couple of slides from what we call the Maths Challenge, the Senior Maths Challenge, and also the team. So we always enter students for the Senior Maths Challenge each year, and then we also put a team of 4 in for the team challenge that takes place at the University of Cambridge. A really great place to go and do some problem solving. So there's a couple of young ladies who are just preparing for the team. It's very competitive, and there's lots of students interested in taking part, and so we do some problem solving as a group, and whittle it down to our 4 students who are going to represent the college. And this photograph in the bottom corner here, that shows one of our successful teams from a couple of years back, actually working at the University Maths Department, doing their problem solving, and they always really enjoy that day out. And this is something else that is really popular with students as well. It's called the Maths Inspiration event that takes place in Cambridge each year. So this is an interactive maths show where they have inspiring speakers who come in and talk about the real world applications of maths. Lots of interesting demonstrations, and because it's so close to us, we always get a nice group of students going each year, and they always really enjoy that. And then lastly, just a little slide in about the recreational activities. The maths department is a really bright and spacious space, and we have lots of students who will sit and work in the corridor doing their maths. There's also an opportunity to relax quietly playing a game of chess, and we've got some other puzzles and games available in the maths area as well. So I hope that this presentation has answered your questions, and thank you for watching the video, and we look forward to meeting you again at some point in the future. So goodbye.